Hey everyone, my name is Daniel Yestopasi, third year BT Lit IE, and welcome to my video. Today, we're diving into something a little more technical, testing the electrical components of your refrigeration and air conditioning system. Before we begin, I'm going to walk you through it step by step, so even if you're not an electrician, and learn some valuable troubleshooting skills. This is super important for keeping your system running smoothly and efficiently, and potentially saving you a costly service call.
Alright guys, so we're checking a compressor. A couple ways to see if your compressor is good or bad. We're checking for if the compressor is shorted, so make sure your meter's on. And when you hear this beep, that means we're getting continuity. Now, from here to the body of the compressor, you should not get any sound at all. And we're going to touch one of the pins. Either one of the pins, doesn't matter. If one of them beeps, then the compressor is bad. So that's a shorted compressor.
This is Craig Migliaccio from AEC Service Tech, and today what we're going over are 8 troubleshooting scenarios which we're going to diagnose using our multimeter on our electric training board for HVAC students. So if you're not aware, we have this whole board, all the parts, the dimensions, how to build this step-by-step over at our website at aecservicetech.com in the articles and the resource section. So now we're going to get started with our diagnosis. Removing faceplates to visually find the problem, I always have them use the multimeter in order to find the problem and then to show me it with the multimeter. We are also using a GFCI plug right here, and we're using it as an on-off switch and for extra safety during the process. And now we're going to get to our troubleshooting scenario 1. So before we get started, right now I have the power off at the GFCI plug, and I'm just going to use these buttons to turn it on and off. Right here is air conditioning mode, so once again the power's off, but if we turn it on cooling and press the temperature down, what should happen is our contactor should suck down and we should have power at the plug so the fan and light will work. And then if we were to just turn the fan on, then we should have power to the fan. And so this is the fan, and the sequencer turns the fan on, but only during heating mode. So if you were to turn this to heating mode and this remains on auto, and you turn the heat up, then we should have our light lit, and then after the lights up, then the fan should turn on, and then when we turn power off, the fan should continue to run for a little bit, just like on a furnace, and then it'll shut off by itself, and that's all due to the sequencer right here. If you want, we already have our multimeter set on voltage for alternating current, and you can see the squiggly line, that's the sine wave, and so we're going to turn our power on for our first troubleshooting example. Now right now, you can see our thermostat is set on the off position, so the only time the fan should be running is when the thermostat's on the on position. So if we do this, then the fan should be running. In this case, we're not even doing that, so that's a problem. And now we're going to test the thermostat and make sure all of our settings work. So we're going to turn our fan on first. So that's good. We can turn our heat on. Looks like heat isn't working. So we'll test that out, and then let's also test our air conditioning, which is cooling, on a service call. Now that our thermostat wire has been replaced and our multimeter is set back on voltage for alternating current, we're going to turn the power on, and we're going to do our test again to find our problem. So fan works, heat doesn't work. So now we're going to go ahead and test. Once again, let's do our baseline from common to our power, so we have 28 volts. And so if we're on heat, then we can measure from common to W, which is our white wire, and you see we have 28 volts.
Tools and equipment. 1. Fundamental tools, wrenches, screwdriver, pliers. 2. Tube processing tools, tube cutter, flaring tools, swagging tools, bending tools. 3. Vacuuming and charging station, vacuum pump, charging station, refrigeration cylinders, or other related tools and items. 5. Electrical test meter, voltmeter, wattmeter, ohmmeter, megger, ammeter. 6. Mechanical testing tools, gauge manifold, thermometer, test kits. 7. Refrigeration materials, copper and aluminum tubing, refrigerants, refrigeration oil. 8. If ever needed, refrigeration trainers.
Some of the tools illustrated here are used mostly for commercial works and are also found in domestic refrigeration and air conditioning servicing. Careless repair procedures are dangerous and should not be tolerated in any service work. Properly chosen and correctly used tools will not only to save time, but will also ensure neat, dependable, and satisfactory job that will result in mutual benefits to the service technician and customer alike. That's all. Thanks for watching.